Welcome to Section 2, Lesson 2. In the previous lesson, we introduced the building blocks of algebraic expressions and the rule for combining like terms. Today, we add the second simplification tool, the distributive property, which lets us expand expressions where a number or variable multiplies a sum or difference inside parentheses. Together, the combine rule and the distribute rule are the workhorse pair you will use in nearly every simplification problem from here to the end of the algebra course. Mastering them at this stage pays dividends through every later section. The reason these two rules are so important is that they convert any algebraic expression into a normalized form where every distinct variable and exponent combination appears at most once, with all coefficients summed. Once an expression is in this normalized form, comparing two expressions, evaluating them, or solving equations involving them all become much easier because the bookkeeping is uniform. First idea on the board. Combining like terms is the workhorse rule from Lesson 1. To combine like terms, you add their coefficients while keeping the variable part unchanged. We will use this rule constantly throughout today's lesson, especially after every distribution step opens up new like terms that can be combined. The reason combining like terms is so central is that it is the only legitimate way to reduce the number of terms in an expression without changing the underlying value. Every other operation either rewrites or expands, but combining is the move that actually shortens the expression. The distributive property is the new rule for today. It says that a number or variable multiplied by a sum equals the sum of the products. In symbols, a times the quantity b plus c equals a times b plus a times c. The factor outside the parentheses gets distributed to every single term inside the parentheses, and the parentheses come off in the process. The distributive property is one of the foundational axioms of arithmetic and algebra, and it is what links multiplication and addition together so they can be combined in flexible ways. Without distribution, multiplication and addition would be two separate operations with no way to convert between them, and most algebraic manipulation would be impossible. Third idea. Most real simplification problems combine the two operations in alternating passes. You distribute first to remove parentheses, then combine the like terms that the distribution exposed. Sometimes you have to distribute a second time after the first round of combining, depending on how complicated the expression is. The order distribute then combine is the default workflow, and it works for nearly every expression you will meet for the rest of this course. The next lesson on nested parentheses will extend the same workflow by working from the innermost grouping outward, but the distribute then combine alternation stays exactly the same. Once this rhythm becomes automatic, you will be able to simplify expressions of significant length in just a few minutes. Quick recap from the previous lesson. To combine like terms, you add their coefficients and keep the variable part unchanged. 3x plus 5x equals the quantity 3 plus 5, all multiplied by x, which equals 8x. The coefficients 3 and 5 do the work, the variable part x is shared and stays put. This rule will combine with the new distributive rule that follows. Now the new rule for today, the distributive property. A times the quantity b plus c equals a times b plus a times c. The factor a sitting outside the parentheses gets distributed to every term inside. After distribution, the parentheses are gone and we have a sum of two products instead of a single product of a sum. Concrete numeric example to anchor the rule. 3 times the quantity 4 plus 7 equals 3 times 4 plus 3 times 7, which equals 12 plus 21, which equals 33. Verify by computing directly. 4 plus 7 equals 11, and 3 times 11 equals 33. Same answer either way, which confirms the distributive rule. The numeric verification is worth doing by hand on a few rounds of practice problems early in this section. Because seeing both sides of the rule produce the same number builds your intuition that distribution really is just an algebraic restatement of how multiplication and addition interact, not a separate magic technique. Now distribute over an expression that contains a variable. 3 times the quantity 2x plus 5 equals 3 times 2x plus 3 times 5, which simplifies to 6x plus 15. Notice that the constant on the outside multiplies through both the variable term and the constant term inside the parentheses, producing two new terms after the distribution. The number of new terms after distribution always equals the number of terms originally inside the parentheses. An important caution: when the factor outside is negative, the negative sign distributes to every term inside. Negative 2 times the quantity x plus 4 equals negative 2 times x plus negative 2 times 4, which simplifies to negative 2x minus 8. The minus sign reaches both terms inside, including the constant. Forgetting to distribute the negative is the single most common simplification mistake, and it accounts for a large fraction of the wrong answers students submit on early Section 2 homework. Always pay extra attention to the sign of the factor that is being distributed. Now the full simplification workflow. 2 times the quantity x plus 3 plus 4x, distribute first 2x plus 6 plus 4x. Then combine like terms. The x terms 5 give us 6x, and the constant 6 stays. The simplified result is 6x plus 6. Distribute first, combine like terms second. That two-step pattern handles nearly every Section 2 simplification problem you will meet. Here is the first worked example. Simplify the expression 3 times the quantity 2x plus 5 minus 4. The expression has one parenthesized chunk and one separate constant outside, so we will distribute first and then combine the constants in the result. Step 1. Apply the distributive property to the parenthesized chunk. 3 times the quantity 2x plus 5 becomes 3 times 2x plus 3 times 5. Notice that the minus 4 sitting outside the parentheses is unaffected by the distribution because it is not inside the parentheses being distributed over. Step 2. Carry out the multiplication on each new term. 3 times 2x equals 6x, 3 times 5 equals 15. So the expression becomes 6x plus 15 minus 4. The parentheses are gone, and the expression is now a sum of 3 terms with no remaining grouping. Step 3. Combine the constants. 15 and negative 4 are both constants and therefore like terms with each other. Their sum is 15 minus 4, which equals 11. The expression simplifies to 6x plus 11, with the variable term unchanged because there were no other x terms in the expression to combine it with. Step 4. The simplified result is 6x plus 11. The original 3-term grouped expression has become a clean 2-term simplified expression that represents the exact same quantity for any value of x. So the answer is 6x plus 11. The big lesson from this example is the distribute then combine workflow in its simplest form. Distribute the factor outside the parentheses across every term inside, then combine any like terms in the resulting sum. The workflow scales smoothly to any expression with a single parenthesized chunk, and the next example will show how it generalizes when the expression has 2 or more parenthesized chunks. A useful sanity check on your distribution: count the terms before and after. The original expression had 2 terms after the distribution, 3x and 5, plus the standalone minus 4, for a total of 3 terms going into the combine step. The combine step merges the 2 constants into a single constant, leaving 2 terms in the final answer. If your term count does not match this kind of accounting, you may have missed a term during distribution or accidentally combined unlike terms. Here is the second worked example. Simplify the expression 5 times the quantity x plus 2 plus 3 times the quantity x minus 4. 2 parenthesized chunks, each multiplied by a different coefficient. We distribute both chunks first, then combine the like terms that the 2 distributions expose. Distribute both parenthesized chunks. The first chunk 5 times x plus 2 becomes 5 times x plus 5 times 2. The second chunk 3 times x minus 4 becomes 3 times x plus 3 times negative 4. Notice that we wrote the negative 4 explicitly with its sign, so the multiplication treats it correctly. Step 2. Carry out the multiplication on each new term. 5 times x equals 5x, 5 times 2 equals 10. 3 times x equals 3x, 3 times negative 4 equals negative 12. The expression now has 4 total terms, 5x plus 10 plus 3x minus 12. Step 3. Group the like terms. The two x terms are 5x and 3x, which we group together. The two constants are 10 and negative 12, which we also group together. The expression becomes the sum of an x group and a constant group, ready for the combine step. The grouping itself does not change the value of the expression, only its visual organization for the next step. Step 4. Combine the like terms in each group. 5x plus 3x equals 8x. 10 plus negative 12 equals negative 2. So the entire expression simplifies cleanly all the way down to 8x minus 2. So the final answer is 8x minus 2. The big lesson from this example is that the distribute, then combine workflow scales naturally when there are multiple parenthesized chunks. Distribute every parenthesized chunk first, then sweep through the resulting sum once to gather and combine all the like terms. The same approach works for 3 or more chunks, 4 chunks, or any number with no change to the procedure. The distribute, all then combine pattern is more efficient than the alternative, where you distribute one chunk, combine, distribute the next, combine again, and so on. The all-at-once distribution makes it easier to spot all the like terms in a single pass, and it also reduces the chance of overlooking a term in a later distribution because you already simplified earlier ones. Consistency in workflow keeps your work clean and easy to check. 3 classic mistakes when applying the distributive property. Each comes from a small slip on the second or later term inside the parentheses, and each is fixable by being more deliberate about every term that the factor outside touches. First mistake, forgetting to distribute a negative factor across every term. A student writes negative 2 times the quantity x plus 3 equals negative 2x plus 3, distributing the negative only to the first term and leaving the second term untouched. That is wrong. The correct expansion is negative 2x minus 6, with the negative sign reaching both the variable term and the constant term inside the parentheses. Second mistake, missing one of the inner terms entirely during distribution. A student writes 4 times the quantity x plus 2 plus y equals 4x plus 8, leaving out the 4 times y product on the third term. That is wrong. The correct expansion is 4x plus 8 plus 4y, with the factor 4 reaching every term inside the parentheses without exception. Third mistake, a sign error on a term that originally had a minus sign. A student writes 3 times the quantity x minus 5 equals 3x plus 15, treating the minus inside as if it were a plus. That is wrong. The correct expansion is 3x minus 15 because 3 times negative 5 is negative 15. Always carry the sign of each inner term through the multiplication. The combine and distribute pair shows up in 4 big real-world contexts. Each one is a place where you would naturally use the algebra without thinking of it as algebra. Cost calculations. A total bill might be the quantity purchased multiplied by the sum of unit price and tax. Distributing breaks the total into the unit price portion and the tax portion separately, which is exactly what an itemized invoice shows. The distribute step turns one combined product into 2 transparent components. Area formulas. The area of a rectangular addition to a building might be the building's length multiplied by the sum of the original width and an extension. Distributing reveals the original area term plus the extension area term, separating the new construction from the existing footprint in the formula. Code optimization. Modern compilers and database query optimizers use the distributive property combined with like term combining to simplify arithmetic expressions before execution. The optimizer reads the expression, applies the same rules we have practiced today, and emits a simpler equivalent expression that runs faster on the hardware. Algebra and compiler theory share a common foundation here: factoring, which is distribution applied in reverse. Section 8 of this course is dedicated to factoring, where the goal is to recognize an expanded sum and rewrite it back into a product form. The same distributive property runs both directions, so understanding it cleanly here makes the factoring section much easier when you reach it. 3 things to take with you from this lesson. The combine and distribute pair will show up in nearly every simplification you do for the rest of section 2 and beyond. First, combining like terms means adding the coefficients of terms that share the same variable and the same exponent. 3x plus 5x equals 8x. The combine rule from lesson 1 is the workhorse, and we used it in every example today after the distribution step opened up new like terms. Second, the distributive property says a times the quantity b plus c equals a times b plus a times c. The factor outside the parentheses reaches every term inside without exception. Always check that you distribute it to every term, and always carry the sign of the outside factor and the sign of each inside term through the multiplication carefully. Third, the standard workflow is distribute first to clear the parentheses, then combine like terms in the resulting expanded expression. The two operations alternate naturally as soon as you have more than one parenthesized chunk in the expression, and the pattern scales to any number of nested or stacked groupings without any change to the procedure. Once you internalize the workflow, simplification of medium complexity expressions becomes a matter of executing the routine without conscious thought, freeing your attention for the harder problems where strategy matters more than mechanics. Coming up next, the lesson called nested parentheses, where we apply the same distribute, then combine pair to expressions that have parentheses inside parentheses. The procedure stays the same, we just work from the innermost grouping outward, simplifying one layer at a time. The same workflow is also exactly what compilers and computer algebra systems implement under the hood when they simplify expressions for optimization. So what you are practicing here transfers to a broad range of computational tools and not just to pencil and paper algebra problems.